Good morning. Sorry, yesterday's video cut off at the very last second, but it got all in, so I didn't want to redo a whole thing just to say goodbye. So you should have at least attempted the homework. Hopefully, you did okay when you checked your answers. Memorizing that unit circle is key. If you don't memorize that unit circle, like I said, memorizing the decimals helps. And memorizing that 0.866. That's radical 3/2. Even those 45-degree angles, those radical 2's over 2's, you'll see that's 0.707, blah, 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 blah. So if you see 0.707, blah, 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 blah on your calculator, that's radical 2/2. So start memorizing your radicals. It's not that hard. There's only a few of them. Or just memorize your unit circle, okay? So it says by using the unit circle, so it says consider the function. Today we're going to do some graphing, all right, of trig functions. You're going to love that. But if you do graph on your calculator, you can't be in degree mode. So if you ever wanted to graph a sine or a cosine function, you now have to put it into radians and not degrees. All right, so just be careful on that. All right? All right. But anyway, letter A. By using the unit circle, fill the table below for selected quadrantal angles. Nice word. You need to have your calculator out today because we're going to be graphing, and I want you to be able to see it on your calculator. All right. So it says, by using the unit circle, fill the table below for selected quadrantal angles. So what's the cosine? So now I'm going to just show you, okay? We might as well just show a little unit circle right here. Here we go. Boop. What's the cosine of negative 2 pi? Well, where's negative 2 pi? Negative 2 pi is actually over here because 2 pi is normally over here, right? So negative 2 pi is over here. What's the cosine of that? The x value of that is negative 1. All right. What's the sine of that value? 0. Okay. Negative 3 pi over 2. All right. What is the cosine of negative 3 pi over 2? All right. So if you look at where negative 3 pi over 2 is, okay, what is the cosine of that? All right. You'll see, all right, this is 0. All right. And then over here, the sine of that value is 1. You can actually just type them in your calculator too. Sine negative 3 pi over 2, enter. Cosine negative 3 pi over 2, enter. It'll give you these values, okay? So this one becomes negative 1. All right. Remember, negative 3 pi over 2 is over here, by the way. All right. Negative 3 pi over 2 normally is here. So negative 3 pi over 2 is over there, and the cosine is 0. Y is 1. Makes sense. All right. This winds up being negative 1 and 0. Negative pi over 2, okay, is the same as pi over 2. And the cosine there, I'm sorry, no it isn't. This is 0, and this is negative 1. Okay. Because it's right here. Cosine of negative pi over 2 is here, okay? Because we're working backwards. Now we're doing 0, so this is just winds up being 1 and 0. Pi over 2 winds up being 0 and 1. And this winds up being, you can go ahead and pause the video if you want, try to get these values yourself, but, I know the unit circle, so that's all I'm looking at. All right, and coming up with the cosine, the x and y value, the x and y coordinate values of those spots on the unit circle. That's how those were created, okay? You can see a little bit of a pattern, but not really. Sorry, this is 1 over here. I think I put negative 1. That's 1. All right, there we go. So there we go. All right, so now let's go ahead and graph. All right, so just using our points that we just created, all right, we're going to say we're going up by 1s here. So this is 1, negative 1, okay? So at 0, the cosine of negative 2 pi, we'll start all the way to the left. We did this since we're going in order, was 1, right? And let's see, the sine value is 0. So we're going to graph two functions here. Actually, let's do one at a time. Let's first do the first one, cosine. So we have 1, we have 0, and we're just plotting the points that we create. We have negative 1, then we go back to 0, and then we have 1, and then we go like this. Fun times. And there's our cosine graph, and we're just going to do one of these bad boys. like this. Pretty cool. All right. If you were to graph this on your calculator, you'd be in radian mode, and I would change my window. Maybe make my x scale, my scale to be pi over 2, since that's what they're going by here, right? And my y scale 1s. And then, my x max would be 2 pi. My y max would probably be like 2 or 3. And you can graph these on your calculator. Nice and pretty. All right. Let's do sine now. I'll do sine in a different color. I'll do purple for sine. And we have 2 pi, and then 1, and then negative pi, then 0 again, and then negative 1, and then back to 0, and then 1. Boom, boom, boom. And you'll see the sine function looks something like that. All right. The sine and cosine function pretty much look like the same thing, except one is shifted over, right? Similar. So the brown one, okay, this was y equals sine x. And the brown one was y equals cosine x. Okay, there we go. All right, let's keep going. Let us see. The domain and range of the sine and cosine functions are the same. State them below in interval notation. Well, what's the domain? These go on forever and left and right, right? So domain here is negative infinity to infinity. What's the range, though? Top to bottom, smallest to largest, it only goes from negative 1 to 1. All right, actually, we got to do brackets here. D. After how much horizontal distance will both sine and cosine repeat its basic pattern? This is called the period of the trigonometric graph. Because these graphs have patterns that repeat, they're called periodic. All right, so what is the period here? Okay, how many horizontal distance will both sine and cosine repeat its basic pattern? How long does it take to repeat it? It goes from 2 pi, 0 to 2 pi. So our period would be 2 pi here. Okay. After 2 pi, that's when it starts to repeat. All right, let's keep going. So it says, now we like to explore the effect of changing the coefficient. What happens when we change the coefficient? So let the transformation, just like the transformation of quadratics or transformations of logs or transformations of any function we've ever done, right? Think about what these numbers mean. The number in front, right? It talks about, it takes care of the vertical stretch or the vertical shrink. Remember that? If there's numbers on the inside the parentheses, that's a horizontal stretch or compression, right? We talked about these things. If you add or subtract a number to the outside, you're going up or down. It's the same thing with trig functions, okay? So use your calculator, sketch and label each of the following equations. Be sure the calculator is in radian mode. All right. So I'm going to let you go ahead and just mess around with that on your calculator. I mean, I'll do a rough sketch of it here, but type these all in your calculator and kind of get like a little rough sketch of it. Basically, if you did y equals 3 cosine x, okay, you'd see it's kind of like, I think it starts over here. All right. And then I'll just do it really quick. Do it really quick. Sorry. Goes over here. All right. Okay, this is what the first one winds up looking like. So basically what it do, it kind of did a vertical stretch, right? Kind of made it more narrow. We know this already, right? So -4, what's that going to do? It's going to reflect it. Remember, it's going to make it more narrow and it's going to reflect it. You see that this one winds up looking like this. That's this one. And then this one, it winds up looking, let's see. If you do, I mean, you could do it in your calculator, but take my word for it. It winds up look something like this. All right. And same thing. I mean, you could play around with your calculator if you want. Okay. And that was this one. y equals 3 halves x, or 1.5 cosine x. Kind of looked over, it kind of like started over here and kind of went to here, like kind of like in the middle almost, right? And then this y equals -2 cosine x kind of started over here and kind of did one of these, right? So it was like a little weird, but I trust that you can try these all on your calculator, but you get the transformations. The positive coefficient is going to do a little vertical stretch to make it more narrow. And the negative is just going to reflect it and make it more narrow, right? Just keep that in mind. Okay. Exercise 3. The basic sine function is graphed below. Without the use of calculator, sketch each of the following curves without the use of your calculator. Okay. So how can we do that? All right. Well, we're never gonna have to do this without a calculator. So instead, I'm not gonna waste time with that. You can go ahead and sketch these on your calculator if you want. All right. It's not that hard though. I mean, you could say the sine of -2 pi. All right. The sine of -2 pi is 0. Therefore, 2 times 0 is 0. I mean, you can do this without a calculator if you want. Like the sine of -3 pi over 2, okay, is -1. I'm sorry, is 1. 1 times 2 is 2. So I'm sorry, yeah. So you have to do it like that, and you get 2, and then you can go ahead and make your. This is without a calculator, but with a calculator you can just get the values, okay? Or you just do 2 sine of 2 pi, get an answer. 2 sine of -3 pi over 2, to get an answer. 2 sine of negative pi. 2 sine of negative pi over 2, and what you'll get in your calculator, all right, is those decimals. I mean, it is 1, -1, 0. You'll get those numbers, okay? So this first one, 2 sine of x, winds up looking something like this. Just kind of, blows it up a little. Kind of just makes it more narrow, right? And then the 4 does the same thing. The 4, is going to be up here. So the 4 is going to be something like, that. And the negatives have the same effect. So you can go ahead and try those on your own. I'm not going to waste your time. All right. Well, that's it. You can go ahead and try your homework if you'd want. All right. The homework is just practicing the graphs. Okay. So, like I said, just what you need to practice and not practice. So, do I expect you to do, like in this first example, wants you to make 5 graphs, 6 graphs? Just make sure you can do it. If you had to take a reading school, you don't have to do it, but you will need this next year when you do calculus. Make sure you can do it. They'll expect you to know how to graph a trig function. So you'll have your calculator. So hopefully you're doing okay with the unit circle and you can memorize that stuff by now. All right. Try your homework. We will continue with this unit tomorrow. All right. Have a great day, guys.